Hello again, BC. Another one of my very short videos. We're going to talk about rectilinear motion again with integration as opposed to taking a derivative to go from position to velocity to acceleration. So suppose we were given a problem and we wanted to, answer all those good questions. Displacement, total distance traveled. When are we speeding up, when are we slowing down, any of those questions that we got so good at analyzing when we originally saw rectilinear motion, or that you've worked on in a physics class before. Right, suppose we were trying to answer any of those things, and suppose that we were given, instead of a position function where we had to take some derivatives, we were given some acceleration function. Let's say 1 plus sine t. And since we're going to be taking some indefinite integrals here, we're going to need some initial conditions. So let's suppose that our initial velocity is 0 meters per second, and that our initial position, let's just say it's 4 or something. Who knows? Maybe 4 meters. Okay. So given acceleration, right, we know that the integral of acceleration is the velocity function. And then we know that we're gonna have to do something with this initial value. Okay, so let's first find velocity and position. So if I want to find the velocity function given this acceleration function, right? Well, I know that v of t, right? V of t is the integral of a of t, right? That's what we know. Right, we're dealing with an indefinite integral again, right? The indefinite integral of 1 plus sine t dt, right? Okay, and we can easily integrate this, right? Antiderivative of 1 is just t, right? And the antiderivative of sine t, right? What has a derivative of sine t? Well, of course, that's just negative cosine t, right? And then we have this plus c, right? And this is my velocity function. Well, how do I find c? I know v of 0 is 0, and v of 0 means I plug in 0 for t, right? So that's cosine of 0 plus c. Well, of course, the cosine of 0 is negative 1. Well, it's positive 1. The negative of that is negative 1, I should say, right? And so we're going to end up with this equation, so c has to be 1. C has to be 1. Now, I couldn't just say, oh, my initial velocity is 0 and plug in 0 for c, right? Because I had to actually say this whole expression has to be 0, right? And this left side of that, right, the thing that we just took to get my antiderivative, this thing right here might not be 0 at t equals 0, right? If it's polynomial, it obviously would be, right? But we aren't dealing with a polynomial here, right? We're not dealing with a polynomial. We have cosine or sine here. So this tells me, right, that my velocity function is t minus cos t plus 1. Okay, well, we said we wanted to find position too, and position is just the integral of velocity, right? Because velocity is the derivative of position. So if I were to take the integral of this thing, the integral of t minus cos t plus 1, right, dt, well, that's just 1/2 t squared minus sine t plus some constant c. And we said that s of 0 was equal to 4. So that means if I plug in 0 here, sorry, this is s of t. If I plug in 0 for t, I'm going to get 1/2 0 squared minus sine of 0 plus c. All of those things are 0. So we're going to get c equals 4. So one of these examples, we had to plug in, we got something different than my initial condition for c, and then the other one, I got the same thing, right? So this would tell us that s of t is 1/2 t squared, I'm going to rearrange some, plus t minus sine t plus 4, and that was my position function. So once we have these two things that we're going to put in red boxes, right? Once we have my two functions here and here, and of course my acceleration, right? These three things you could analyze heavily to figure out anything, right? Like we said, when is a particle speeding up? When is a particle slowing down? Where is it at t equals 5? What's the velocity at t equals 3? Any of those questions you could answer, right? We would just be plugging in numbers. So I don't want to take up any time to do that. I just want to remind you that this is how we took the integral and we plugged in with the initial condition to find that constant value, that c value when we integrated, that we get when we take an indefinite integral. All right, so I hope this was helpful. And again, I'll throw up a few practice problems from the book should you want to see them that sort of deal with a similar concept here. They will probably have to require you to analyze them a little bit, but I didn't do that here because I feel like we're pretty well versed in that. If you would like to see me to go over any of those concepts when we return to school, please let me know.